Welcome all in this electrochemistry numerical lecture. Today we will see the numericals based on moving boundary method, in which we have to calculate the transport number of cation as well as transport number of anion. Regarding this, we will see the first numerical. You can see in the screen is read this numerical one or two times to get what you have given, with the help of which you can calculate or you can solve the numerical. In the moving boundary experiment, the boundary moved only 38.7 mm in 20 minutes where steady current. That means current is given, time is given, and length is also given. Just look all these values and their units. Take all the quantities in only one system, either it may be a CGS or either it may be a SI system. And that the tube has a cross sectional area, so small a value is also given. Concentration 0.02 mole per dm cube, that is also given. So convert all these into only one system, that is either SI or CGS. So you can look here, C is equal to 0.02 mole per dm cube, that is nothing but 0.02 divided by 10 raised to minus 3. So which become 0.02 into 10 raised to 3, that is nothing but 20 mole per meter cube. In this way you can convert length in mm, convert it into meter, so it becomes 3.87 into 10 raised to minus 2 meter. Area of cross section 1.350 into 10 raised to minus 5 meter square. Electric current 1.82 into 10 raised to minus 3 ampere. Only time which we have to convert, it is in minute, so convert it into seconds. So 20 into 60, that is nothing but 1200 seconds. By getting all the quantities in one system, you know the famous formula, that is T plus is equal to 96,500 into C into L into A divided by I into T. Put up all the values in this formula and you will calculate transport number of cation, that is equal to 0.462. Now if you know the transport number of cation, you can easily calculate the transport number of anion with the formula T plus plus T minus, that is equal to 1. So just subtract this value, that is transport number of cation, from 1, you will get the transport number of anion or transport number of Cl minus ion. So it is 1 minus 0.462, that is nothing but 0.532. In this way you can calculate both transport number of cation as well as transport number of anion. Now in the next numerical, see what is given. Speed ratio of silver and nitrate ion is given. In a solution of silver nitrate between silver electrode, it is 0.916. And with the help of this, you have to calculate transport number of silver as well as NO3 minus, that is nothing but transport number of cation and anion, which we have to determine. So formula is gamma is equal to V plus upon V minus, that is equal to T plus upon T minus, and it is given 0.916. So T plus upon, put up the value for T minus, it is 1 minus T plus, and its value is 0.916. Now you can write or rearrange T plus is equal to, this 1 minus T plus is in denominator, it goes to the right hand side and become in multiplication. So 0.916 into 1 minus T plus. So we have to solve this bracket. So 0.916 minus 0.916 T plus. Now this is the value for T plus. Now take T plus terms to the one side, to the left hand side. So it become 1.916 T plus, that is equal to 0.916. Now you can calculate T plus. It is in multiplication, goes towards the right hand side. In dividation, so 0.916 upon 1.916, and its answer is 0.4782. Now this is the transport number of cation, that is nothing but Ag plus. Now subtract it from 1, you will get the answer, that is transport number of NO3 minus. So it is 0.5218. So in this way you can calculate transport number of Ag plus as well as NO3 minus. Now in next slide, that is the last numerical of this lecture, calculate the transport number of H plus and Cl minus ion with the help of moving boundary method, and data is given, that is concentration is given, weight is given, moment of boundary, that is L is given, small a is given, and atomic weight of Ag is 108. Now we have to calculate the transport number of H plus and Cl minus ion with the help of this all data. So weight is given, so how we can calculate it? By using the same equation, just a small change, that is transport number of H plus is nothing but equal to L into A into C into 96,500 upon 1000 into I into T. We have to calculate I into T first of all. So I into T is nothing but quantity of electricity which can be determined as below. With the help of equivalent weight we can calculate it. Equivalent weight is equal to 96,500 into electrochemical equivalent, that is the Z. So Z is equal to 108 by 96,500. With the help of famous equation W is equal to ZIT, which comes from the laws of electrolysis, and we have to put up the values, and after substituting the values you will get 0.12 is equal to 108 upon 96,500 into I into T. So you can write for I into T, it is 0.12 into 96,500, 108 will be going to denominator. L is given, A is no, C is we also know, that is 0.1, and putting all the values in this equation, transport number of H plus, and after calculating you will get transport number of H plus is 0.8437, and if you know the transport number of cation you can easily calculate the transport number of anion, that is transport number of Cl minus ion is equal to 1 minus transport number of cation, that is 0.8437, and you will get the answer 0.1563. So in this way we can calculate transport number of H plus as well as transport number of Cl minus ion. Formula which we use, that is transport number of H plus ion, is we have discussed here. So solve same numericals based on this formula, so you will become more perfect. In this way, on moving boundary method there are 2 to 3 types of numerical present, so we must solve it for getting a better score in your exam. So thank you so much. We will meet in the next video lecture.